Wi-Fi channel or network. I don't know how it's said, but you can connect with Wi-Fi with this sources network and with the keyword written in the wall. And we have a small modification of the program because we have an additional talk this afternoon by me. You met him yesterday. So we will be having a coffee break at 4 and then a couple of talks after the coffee break that we will be ending like at 5:30. So one talk more. And I think we can start with the talks. This morning we will have Begoña García as the first speaker. He's coming from the I don't know in English. It's a Pyrenean Ecology Institute. Maybe it's how do you say it in English? It's coming from Zaragoza, and she will be talking about their work with historical photographs and different stuff.
Lo que queráis. Voy a necesitar es... Igual me siento aquí. Sí.
Sí. Si te sientas, lo más fácil es este, porque este funciona bien.
Sí. Si no te...
Si te sientas, yo creo que lo mejor.
¿Tú sabes cómo meter que sea en diaporama? Ay, se ha quedado cortito. El pointer está. A ver, vale. Entonces, si usas este. Bien. Vale, esto lo apago. Está perfecto. Gracias. Si acaso me avisas cuando me queden 5 minutillos. ¿Sí? Gracias. Good morning, everybody. First of all, thank you very much, Miguel and Letitia, for inviting me and having us the opportunity to share with you our contribution to put in value some historical information. Okay, let's start. Landscapes are changing worldwide and at different rates in different places. And changes in land cover means changes in biodiversity too, because their environmental conditions change. So either in terms of community reorganization, loss, or increase of species. So it seems nice or interesting at least to assess potential changes of biodiversity driven by past changes of land cover, and also taking benefit of the predictive power of past to include our understanding of mechanistic processes of past changes to assess the future impact of global change on biodiversity. Okay, repeated images through time are very faithful and very integrative ways, sources of information to discover not only how the landscapes were in the past, but also how they transform. And there are many different sources now, and each one has advantages and disadvantages because they cover different spatial and temporal scales and provide information at different spatial resolutions and temporal depth. As an example, in the last 1-2 decades, new technologies are providing us with very interesting and promising information, able, for example, to track changes in the volume or the height of individual elements like shrubs or trees. Before that, satellites are sending spectral bands from Earth's surface, which are sometimes used as proxies of biodiversity, or at least the framework where biodiversity changes. Even before that, around the 50s or earlier, depending on the regions or the countries, planes have taken lots of zenithal pictures of the terrain surface. And deeper in the past, we have the oldest pictures which date back from the middle of the 80s, more or less, and they were taken basically for touristic purposes, at least in the very nice places like the mountains I'm going to talk about. Okay, what we can see here clearly is that there is a trade-off between detecting deeper changes and increase the spatial resolution. So in this talk, I'm going to talk about insights of land cover and how they affect to biodiversity by using repeated images. It's a long-term ecological research perspective, considering that long-term means older than 10 years, let's say, which is not very historical, maybe. Okay, the place where we have been working is the Ordesa and Monte Perdido National Park, which is in the south part of the Pyrenean range in the Iberian Peninsula. It's a small park, it's only around 30,000 hectares. And as a typical mountain terrain, it's very diverse due to this large environmental heterogeneity. If you see here, for example, a profile of altitudes, you can see it's very rough, and due to deep canyons, the altitude goes from 650 till 3,350 meters, which translates also in high heterogeneity of microclimates, and also in very many different kinds of European labeled habitats, like 116, many of them also of European interest. And also is one of the best prospected areas in Spain, in the Iberian Peninsula. So we think there are about 1,400 vascular plants right now there. Okay, here you have some pictures of the nice landscape of this national park with both deciduous and coniferous forest, and also grasslands, which are in the higher part. And it's very, they cover a lot of, more than half of the surface of the national park, and shrublands too. Which are the main global change drivers? Well, as a typical mountain too is climate change, of course. We know that because there is meteorological stations that has been recording temperatures since 1982. But basically also the abandonment of traditional land use because of the drastic reduction of livestock density in the 50s, around the 50s, due to the migration from the rural areas to the cities. And livestock is taken to the subalpine meadows, and those meadows are supposed to be the ones with highest biodiversity in the park. Okay, so we know that part of the landscape is maintained by this traditional use, and we wanted to know, we wonder what consequences might have these changes in land cover on biodiversity. Our first approach is satellite imagery. So we have estimated the NGVA, like as a productivity index, or how green, let's say, is the landscape. The resolution is really high. It's high. It's 30 meters high, the pixels. And we have like 2 images per month, more or less. And it was taken from Landsat, and analyzed, all these images were analyzed through the Google Earth Engine platform. What we have found is that if we compare 2 decades, we are starting in 1999 because there is a lot of pictures. Before that, it's less trustable, let's say. So if we compare the first decade with the second one, we can see how the landscape, or the greenness, is changing in the park. It's clearly becoming greener. Okay. And as part of another ongoing project, on another long-term ecological research project, we have deployed more than 150 temperature sensors in the park in many different kinds of habitats that we have grouped in 3, like forests, open vegetated, including grasslands and shrublands, and also rocky places. And then we are also making vascular plant inventories in those places, which turned out to cover 600 plant taxa, which is almost half of the whole flora of the national park. And it's, so we have a very good representation of the flora there. So this is what we can this is the kind of images we can get with these Landsat images. Let's say, for example, P4 is one of the places of a study where we have made an inventory. And we can see here, we can analyze how each one is changing through these 20 years, 21 years. This is a rocky place, which is supposed not to change very much. And here I have sorted out all the 150 places of a study according first to the habitat type, forest, open vegetated and rocky. And then in green, you see how intense it was the NDVA at the beginning of the study. And in black, you have how much it has changed through time, okay? So what we can see here is that first that forests have changed the least in our study area, and also that places with high NDVI change less than the ones with low NDVI, and also that the rocky places are the ones that are changing fast in a relative way. Okay, how these changes affect local plant diversity. With these inventories, we know how much and what kind of diversity we have in those areas. So remember, we are talking about almost half of the flora of the national park. And as you see here in this picture, rocky places are not the richest ones. They are in open vegetated, these subalpine grasslands mainly. But what we have in rocky places, it's comparatively with the other habitats, is a high proportion of endemic and threatened plants. So they have the most singular and vulnerable flora in those rocky places. Good. Then let's move to another approach. In this case, we are comparing aerial photography taken from planes. That's what the first ones are what we call here the American flight in 1956, and also the National Plan of Aerial Orthophotography. And the resolution is not that good. And we have made this analysis based on human interpretation. Okay, here after combining hundreds of pictures, we have the whole image of the national park, both in 1956 and in 2018. And as you can see here, there are two areas that look very different. So they have really transformed over these 50 years. What we found here is that this kind of approaches, it has good resolution to track changes in the tree line here, as you can see, in the peripheral area of the national park. But it's not that good for distinguishing, for example, rocks from grasslands in the upper part, which are, again, let's remember, is the ones with the highest biodiversity. Okay, if we compare then, inside the national park, changes are not very, places are very, very stable, and the main change is from sparse forest to dense forest. And outside the national park, there has been more transformation, but again, they are the same habitats are the ones implicated, okay? So in general, because we have used large categories or habitats, what we applied was a patch analysis, and then we can see here that the edge of the polygons that we have drawn has decreased, and as well as the number of patches. What has increased is the size of the patch because they have merged, and the Shannon index has also decreased. And also that most of the changes occurred below 2,100 meters, but that's probably because we have not very good resolution capacity. If we try to apply this to our local biodiversity, those sites that we are following in a very intensive way, like here, we have not enough good resolution, except in some places that, like the one below the pictures, where we can see that the cattle exclusion has transformed, the vegetation inside has transformed very fast. Okay, again, we can wonder, do land changes overlap populations of these vulnerable or endemic plants? And it happens that historical records of plants are not are not very good either, because plant botanists didn't have GPS in the old times. So our records come at 1 square kilometer of resolution. So what we did was just to overlap the map of changes in the national park and the maps of the presence of these vulnerable or endemic plants. And as you can see here, they hardly overlap. So fortunately, those changes are not affecting the most singular plants. And then our third approach is repeat photography, very old photography. So what we call the ground-based photographs, or they are also called oblique pictures, which must be taken usually from or gathered from public and private collections, postcards that were very common at the beginning of the 19th. So the good thing with this approach is that they have a very good temporal coverage. The bad thing is they have very low temporal resolution. There are not very, let's say, not very many repeated images from the same point to the same landscape. And here you can find some pictures comparing photographs taken like 1 or more than 100 years ago. So the resolution sometimes is really good. It's very good to be able to distinguish how habitats have been transformed. And here also. And also this is a very nice picture of a picture of a river valley, Pineta Valley. And there is something totally different in these images compared to the former ones. And it is that zenithal images don't consider rugosity. So in our national park has lots of cliffs, for example, or areas with a slope higher than 45 degrees, and means that if we stretch the surface of the national park, it turns out that we have 20% more surface than we have in B-dimensional maps. And that's good for all kind of organisms living there. So we invented a kind of analysis comparing pairs of historical and current photographs, overlapping the visual, not hidden part of the photographs on a digital terrain model with the aid of ArcGIS Earth. And this you can see how we work it. And using 28 pairs of photographs, we were sampling like 11% of the map surface, this bidimensional map, but 30% of the real surface of the national park. And what we found again is that, as previously also mentioned, forest is the, grasslands and forests are the ones that are changing most. And then we also modeled the probability of change with a generalized linear model and a binomial response, and found that patch size in a negative way and altitude in a negative way were some significant variables in that model. And also the cliffs had a much lower probability of change than forests, shrublands, and grasslands, for example. And then some years later, we discovered there was a Swiss program, the WSL mono plotting tool, and then we tried it with this new analysis system, which means comparing pairs of photographs, another digital terrain model, and also control points to make the images to merge somehow, and then you plot, you make your polygons in both the old and the current picture. And again, using 9 pairs of photographs produce a similar result as the previous analysis. Forests are the ones that have transformed most, as well as the screes, which did not appear earlier. We again modeled the probability of change with a generalized linear model. And we found here, for example, that altitude and patch size, again, were very significant variable. Together with another one that we include is the relationship between the edge and the area. But also that distinguishing between screes and cliffs, which are different in the degree of a slope and the percentage of slope, were very different. So cliffs become completely stable in this new analysis. What we are trying to do now is to expand the project to other national parks, because we know they are very much visited for touristic purposes. So there are many available photographs, old photographs, and we started last year in summer. And we are requesting now people to help to repeat pictures. We have made a preliminary list of 500 pictures in all those 6 national parks. We have opened a web page where we offer a list of pictures for people to be able to recognize some landscapes, and then some advices also on how to repeat the pictures as the best possible. We haven't got very many yet, but the ones we have got, they are really good. Like this one, you can see. This is in the Guadarrama National Park, or these ones in the Aguas Tortes National Park too. So they are really good. People are doing a very good job. So just to sum up, repeated images can be used to assess how land cover changes potentially affect biodiversity. And we have seen that imagery from contemporary satellites are very suited to track detailed and extensively changes in productivity. So they can tell us about potential increase of plant competition for local biodiversity. Other aerial photographs taken from airborne platforms are also very suited to track shifts in the tree line and transitions between large habitat categories. So they can tell us about deep changes in biodiversity communities, the whole community, but both approaches miss an important part of the land surface in mountains or rough terrains. And so historical ground-based imagery might not have very high spatial resolutions of the former ones and coverage, but they are the oldest and most faithful sources of information for land cover changes, and the only ones able to assess cliffs, for example, which shelter, in our case, the most vulnerable plants. So we propose they are refuge also for biodiversity. And that's all. Many thanks.
No, ¿qué diga Begoña? So, if anyone has questions for Begoña?
Can you hear me? Yeah, it's maybe a naive question, but I was wondering if, okay, putting aside the artistic interpretation, if paintings could be used in the same way that the old photographs you're using.
I think so, but they are not so trustable. I mean, I think someone told us yesterday that, I mean, pictures are completely trustable. I mean, you are not interpreting anything, you cannot manipulate anything, you cannot. So that's what I think the good point of historical pictures. They are very faithful.
Hello, it's very, very interesting communication. At any time, do you have the idea to cross this information with some maps which have been done, for instance, which classified the biota and so on? Old maps, I mean, cadastrial and so on.
No, we haven't tried it yet.
Okay.
So, why do you think that the rocky slopes are being lost? It's because shrubs are colonizing them?
Yeah, I thought they were very permanent. So it was a surprise for me too, because some screes, some of them are really very stable, but some others have been very, colonized very fast, both by shrubs, but also by forest, so by very big trees too. So, yeah.
That seems like a very unstable system. That it's like moving, and that's why they were there because of the moving rocks and so on. But it's a surprising.
Yeah, but I think there are different kinds of screes. I mean, some of them are really active and some others are very unstable. So depending on how much they were used in the past, for example, if there were flocks of sheep, for example, browsing there, most probably they are very unstable, but some of them are terribly stable. So they vary a lot, but cliffs are completely stable. And there are plenty of these plant species at the limit of distribution, for example, besides endemic and threatened plants. So they are really very good refugia for them.
If we don't have any more questions, yes, but thank you, Begoña.
Thank you.
And we have for